YouTube channel. In this video I'm going to explain you about operational amplifiers. Generally most of the electrical engineering students have problem with electronic subjects, so this time I decided to select this topic, and operational amplifier is a very important topic. And before going deeper into the topic, let us firstly learn the basics, like what is definition of the operational amplifier, like how you define an operational amplifier, and then we'll go to the block diagram of the operational amplifier, and then its characteristics and operational modes, transfer characteristics, and then finally applications. Okay, so these are the topics that will be covered in this session. Okay, so to define an operational amplifier, what is operational amplifier? Like, we have learned about amplifier, but what is this operational amplifier? What is special about it? Yeah, operational amplifier is a high gain direct coupled AC and DC signal amplifier. Okay, so we'll come to know how it is by understanding the block diagram. So let us start from the block diagram. So the block diagram of operational amplifier consists of 4 stages, and it is like this. It is dual input, so it is having V1 and V2. The first stage of the operational amplifier is dual input, balanced output, differential amplifier. Okay, see, dual input means it is having 2 inputs, and balanced output means the output is taken at both of the collector terminals. I will show you the diagram. It will be like this. These are the collector terminals and these are the emitter terminals, and the input is given at this base terminal like this, V1 and V2. V1 and V2 are these inputs, and the outputs are taken at the collector terminals like this, that is VC1 and VC2. So these are the output terminals. Since the output is being taken from 2 collector terminals of this amplifier circuit, it is called as balanced output. Okay, and now the second stage is dual input, unbalanced output, differential amplifier. Okay, so the second stage looks like this. So this is how the dual input unbalanced output differential amplifier looks like, and here we are taking the output at this terminal only, V0. So it is called as unbalanced output. And so this, you can see that here this is a cascaded differential amplifier pair, right? 2 differential amplifiers are connected back to back, and hence it is called as cascaded differential amplifier. Okay, and here the output is unbalanced, so only one is there. And coming to the next stage is a level shifter, and the next stage is a power amplifier. So here finally we take V0. Okay, generally the final stage of any public addressing system must be having a power amplifier, that is must and sure. And also observe that these 2 circuits are connected like this. This VC1 is connected to V1, and this VC2 is connected to this V2, and there is no coupling in between these 2 stages. That is, it is not coupled by the use of any capacitor or a transformer or anything, so hence it is called direct coupled. Okay, there is no coupling, there is no coupling element between these 2 stages. And also see, these two amplifiers are directly connected back to back. So the gain of this amplifier, say A1, and the gain of this amplifier, say A2. So the total gain will be A is equals to A1 into A2. So the gain is very, very high, and hence we can say that this operational amplifier has high gain. Okay. And now, since there is no coupling, since there is no capacitor used as for coupling, the DC signal is also allowed to the next stage along with the AC signal. Here, the DC signal is also amplified along with the AC signal, and hence it is called as AC and DC signal amplifier. Okay, and this is how we define an operational amplifier. Okay, and now let us see why we use a level shifter in the operational amplifier circuit. Since the DC is also allowed to the next stage, the DC signal is amplified along with the AC signal, and when you are sending this kind of input, the DC signal along with the AC gets amplified, and the output becomes like this. That is, the zero reference is displaced by some amount, so it must be shifted to its original, that is zero value. So hence we use a level shifter. That is, it converts, it shifts the output from this to this. Okay, so to shift the DC level to this zero, or that is with respect to ground, we use a level shifter. Generally, a level shifter is simply a CC amplifier. This is VI, and here it is VBE. Okay, so what is the equation? Vi minus VBE minus V naught equals to 0. So V naught is equals to Vi minus VBE. Vi here, in the sense, the output at this point. Okay, this is the VIA in this case. So this VI is consisting of AC and DC as well, and this VBE is a DC. So when you are subtracting this from this, the DC is eliminated, and hence you will be getting only pure AC at the output. Okay, and that is about the level shifter. And let us see about the power amplifier. Yes, power amplifier, in this case, what are we using means complementary symmetry class B push pull power amplifier. Okay, this is the push pull amplifier that we are using in this circuit. I will show the diagram as well. So this is how a complementary symmetry class B push-pull amplifier looks like. So why we have given this name, it has a reason. Here we are using a NPN transistor as well as a PNP transistor, and both the bases are connected to the same power source. So this transistor will be turned on when we give a positive signal, and this transistor will be turned on when we give a negative signal. Meanwhile, this will be in off position. That is, when one transistor is turned on, the other transistor is turned off. When one transistor is turned on, the other transistor is turned off. So that is, hence it's called a push-pull amplifier. In this, the transistors must be identical to get a symmetrical output. That is because in one cycle, this cycle is obtained by working of this transistor, and this cycle is obtained by working of this transistor. In order to get a symmetrical output, both the transistors must be identical, and since they are connected back to back, this is called complementary symmetry. And class B means each transistor, like say this is T1 and T2. T1 works for this cycle and T2 works for this cycle, and each transistor works for an angle of 180 degrees, and hence it's called a class B push-pull, and hence it's called class B push-pull amplifier. Okay, and this has excellent conversion efficiency and excellent impedance matching, and the output resistance is also very low. And So why we are going particularly for this type of particularly this type of power amplifier is that is it does not have any bulky elements like transformers like in class A push-pull amplifier. So it is very suitable for fabricating on an IC, and hence we go for this type of power amplifier. Okay, so this is it about the definition and the block diagram of operational amplifier. Now I'll be explaining about the characteristics of an ideal operational amplifier. Okay. So the main characteristics of an ideal operational amplifier is AV is infinite, that is it has infinite gain, and its input resistance is infinite, and output resistance is 0, and bandwidth is infinite. Okay, so these are the main characteristics of ideal operational amplifier. This is very important to keep in mind, and I'll tell you the reason why it is so. Here the high gain, that is infinite gain, is due to the cascaded differential pair. Okay, since we are using a cascaded differential amplifier back to back, so the gain will be multiplied and we'll be getting infinite gain, I mean in the actual case, or else otherwise high gain in the practical operational amplifier. And the input resistance of the operational amplifier is due to a current mirror circuit. Here we are using a current mirror circuit for stabilizing the operating point that I have not explained in this video. If you really want me to explain that, I'll be explaining it in another video separately. And current mirror circuit is nothing like, it's just like a current source. Since the input impedance of a current source is infinite, practically here also its input resistance is infinite. Okay, and why this R naught is 0? Yes, since the last stage is complementary symmetry class B push-pull amplifier, its output resistance is 0, and hence this the output resistance of operational amplifier is also 0. See here the last stage is power amplifier, and here the power amplifier which we are using is this push-pull class B complementary symmetry amplifier, and since its resistance, output resistance is 0, here our resistance is also due to is also 0. Okay, and the bandwidth is infinite because it is directly coupled. Since we are not using any capacitors for coupling, there is no kind of tuning circuits, like we are not using any capacitors or RC circuits. So since it's directly coupled, the bandwidth is infinite, and practically it is in the range of megahertz. And that is it about the characteristics of the operational amplifier. And let me show you the symbol of operational amplifier. Operational amplifier looks like this in a triangle form. It has two inputs, V1 and V2. This is positive VCC and this is negative VEE, and here we are taking the output V0, and A represents the gain A, and this is plus and minus, that is we call it as inverting terminal and non-inverting terminal. Okay, and here this V0 is obtained by V0 equals to this gain multiplied by V1 minus V2, that is A into VID, that is differential voltage. It is obtained here, VID. Okay, so this is all about what an operational amplifier basically is, and what does it contain actually, what are its characteristics, and what does it look like, I mean symbolically. And regarding regarding this operational modes and transfer characteristics and applications of the operational amplifier, I'll be explaining it in another video since it's a very lengthy topic. And if you like this video, just give a thumbs up, and if you have any doubts, just comment down in the comment section. I'll be happy to explain you. And if you feel this video is helpful, just share it with your friends, and don't forget to subscribe to my channel. And yes, press the bell icon to get updates about my next video. Stay tuned, and thank you for watching. Bye bye.